Hopefully by now we are all super pumped to go analyze and visualize some data in Observable. But that all kind of requires one key ingredient we haven't talked too much about yet, the data. So how do we get data into Observable? Depending on the size and location of my data set, there are a few different approaches I can use. So let's take a look. If I have a really small data set, I can include it directly as code content in my notebook. This is what we call inline data. For example, I could manually create a little data set about some books I've read and the way I'd rate them. Perhaps as an array of little objects with titles, authors, and ratings. Or perhaps I have a little set of data in a spreadsheet, and I want to get this into Observable. To do that really quickly, I can select the headers and cells that I want to use, copy that content, just going to Control-C here, and back in my notebook, I can paste these into a cell with a little JavaScript template literal. So I'll paste this in between these two backticks. As we can see, when I paste from a spreadsheet, usually what I get is the data in tab separated values format. So I have a tab between each of my columns here. Okay, so now I've got some raw data in text format. To get that into a nicely formatted JavaScript array that I can work with, I can use a library like D3 to parse that text data. Now, I don't need all of D3 to do that. It's kind of a big, powerful library. I can just use the module D3DSV, which contains some utility methods for working with this type of tab-separated or comma-separated data. So I'm going to require this D3DSV module. Now I get a D3 object. And that will give me a nice little TSV parse method, which I can run on my data to parse it into a nice JavaScript array with these nice little objects where each of my data points has its columns labeled. So for really tiny data sets like this, manually entering the data into a code cell or inlining the data is a great option. But what if my data set is a little bit too big for that? Well, if I have or can get a local file with my data, I can upload it to my notebook as a file attachment. For example, here's an Airtable with some resources from Black Tech for Black Lives. I want to get this into my notebook, so what I can do is download the comma-separated values file, or CSV file, which is a really easy, convenient format for working with data, and most spreadsheet programs give you an option to download or export your data into CSV. Cool, so now I have downloaded a local file with that data. To attach this file to my notebook, back in my notebook, I'm going to go up to the top to the Notebook Actions menu, these three dots at the top, and the first option here says File Attachments. I'm going to click that to open my File Attachments pane. Now I can drag and drop files here to upload them, or I can use this button to upload a file from my computer. Okay, so once that upload finishes, I see my CSV in my File Attachments pane. Right now, it shows that this is unused. That's because I haven't referenced it anywhere in my notebook. So let's fix that. In a new cell, I'm going to use Observable's built-in file attachment function to access the file I just uploaded. Now I'll notice that as soon as I open this parentheses, I'll get an autocomplete option for any files that I have attached to my notebook. In this case, just the one. So I'm going to use tab to autocomplete that. And there's actually an even quicker shortcut for this. If I look at my file in the File Attachments pane and click the three dots next to it, I see an option to copy code. And that's going to copy this call to file attachment for the file that I want. Great, so let's give this cell a name. And as soon as I run it, I get a little file attachment object representing my file. Now, probably what I actually want to work with is the data inside the file itself. To access that, in this case, it was a text-based file, so I can use the file attachment text method to get the text data inside of that file. But now this is just raw text, and I probably want this data nicely parsed like before. So again, I can use D3, and this time I'm going to use the CSV parse method because we've got comma separated and not tab separated values. I actually also need to add an await here because this text method actually returns a promise to get the text out of the file, and that could take a second. So I need to await for that to come back until I can pass it on to the parser. So now I get my data nicely parsed out into little JavaScript objects in a nice array, like before. Now, just a note on dealing with promises like this. If I separate out this call to the text method into its own cell, and let me give that a name, and then in another cell, I reference that text value in my call to CSV parse, I don't actually need the await here. That's because Observable will automatically wait for the promise in this text cell to resolve before running this cell that references it. Check out our Introduction to Promises notebook to learn more about how Observable handles promises like this. In any case, now I have my file nicely parsed out into a nice little array of objects, just like before. So now I can work with this however I want. Now in this example, I used a CSV file, but I can use file attachments for whatever type of file I want. If I upload a JSON file, for example, I actually don't even need to parse out the data with something like D3's CSV parse. I can use the file attachments built-in JSON method to get that JSON data out from that file directly. I can also upload files that aren't even data per se, like maybe an image that I want to use in my notebook or in my visualizations. File attachment has a handy image method for that. Beautiful. So that's a brief overview of working with file attachments, which are super handy for those small to medium-sized data sets. You can read more about them in our file attachments notebook. Now, let's not forget that if I have some data in a named cell in a public notebook, I can import it into other notebooks. So if I'm browsing Observable and I come across some data that I want to play with, like maybe this letter frequency data, I can import that data into my notebook, just like I can import any other named cell using this import syntax. Ta-da! Check out our video all about importing cells to learn more about how that works. Now, what about if my data isn't in a local file but is hosted on the web somewhere? Well, since we're working in JavaScript, I can fetch a file or resource from the web to pull it into my notebook. Say I want to use some data that's publicly accessible on the web. For example, this budget data from the City of San Francisco's Open Data Portal, which has a public API I can use without a token. I'll get the endpoint for that data, and back in my notebook, I'll put this in a new cell as a string that I'll name URL. Now I can use JavaScript to fetch the resource at that URL, and this will give me a promise to a response object. And Observable will automatically wait for that promise to resolve. Now in this case, I know that this file contains JSON data. So in a new cell, I could call the JSON method on the response. There we go, I get some data. Now there's a little problem with this code as I've written it. If I rerun this cell that calls the JSON method, now I'll get an error. That's because the JSON method actually consumes the response body data as it reads it. So in that way, it changes or mutates the response object. In general, we want to avoid mutation like this, especially across cell boundaries, because it breaks or conflicts with the reactive way that Observable runs my code. You can learn more about the reactivity of Observable in our reactive data flow video. So in this case, it's actually better to pull this all into a single cell. I just have to remember to await this promise before trying to call the JSON method. I can make this whole process of fetching JSON data even quicker by using the D3 fetch module, which wraps the fetch API with some convenient methods for working with JSON and CSV and some other common data types. So if I require that module in here, I can then use my D3 fetch JSON method to directly fetch and parse data from the URL. So there we have a few options for pulling data into my notebook from a public resource on the web. Now, keep in mind, I can only fetch from HTTPS sites that have CORS enabled. Now, what if I'm trying to pull data from an API that isn't public like this, but requires an authentication token or some other secret? For example, maybe I want to use NASA's API to pull some Mars weather data into my notebook. So back in my notebook, I'm going to want to fetch from this URL, but I don't want to enter my secret API key or any private or sensitive information into a cell's source code, because then it will be saved in the notebook history. Fortunately, Observable allows me to store secrets in my account and access those securely from my private notebooks without exposing their values. If I go to my account settings page, on my settings page, go to the Secrets tab on the right, I have the option to add a new secret to my account. Let's name this one NASA API key. And usually I would put some super secret value here, but in this example, I'll just use the public demo key that NASA provides. Okay, once that's saved, back in my notebook, or any private notebook, instead of entering my secret directly, I can use Observable's built-in secret function to access the value of the secret that I just added. And I get that as an autocomplete option here. So I enter my secret's name in the secret function, and I can embed that in my URL using this JavaScript template literal with my $curly syntax. As an extra protection, the first time I call the secret function, I'll have to grant the notebook permission to access my secrets. Once I do that, ta-da, I can access this private API and get the API data into my notebook. Now, only private notebooks can access secrets. Public or shared notebooks can't, because that would defeat the whole purpose by exposing your secrets to the world. You can read more details in our Introduction to Secrets notebook. Okay, so that sets us up well to work with data in APIs. Now let's consider one more case. What if my data is stored in a database? Now on our user settings page, you might have noticed the Databases tab on the right-hand side. This is where I can set up a database connection to allow my notebooks to query live data from a public database. Observable offers connectors for several popular databases, including MySQL and Postgres. So if my database is supported, I can create a new connection by entering all of the details here. The user credentials I enter should ideally be for a read-only user, restricted to only the tables and columns that I actually need. Now, I'm not going to show you all of my real credentials here, but once I've got a database set up, back in my private notebook, I can now create a client to access the database using the built-in database client function. And I'll pass it the name that I gave my database when I set it up. And like with secrets, the first time I try to access one of my databases, I'm going to have to confirm that I want to give this notebook access. Great, so now I have a client to talk to my database. Let's give this a little name. And this database client gives me some handy methods to work with my database. For example, I can use describe with the name of the table I'm interested in to inspect the schema of that table. And I can use the query method to provide a SQL query string. Look at that. Now this is still good old reactive observable, so I can even make this query dynamic by adding a reference to another cell's value. For example, maybe I want to add a little select input with a location value that I want to use. I can add a where clause and use my curly braces to insert that value into my query. Now I have a reactively updating dynamic query. Pretty cool. Check out our video on user input and interactivity to learn more about how this input works. Once again, keep in mind that these database connectors only work in private notebooks and can only connect to public databases. For more details, check out our Connecting to Databases notebook. And for more options for working with private databases like those hosted locally or on a VPN, check out our Self-Hosted Database Proxies notebook. Whew, that was a lot of ground we just covered. We saw how we can manually enter data inline. use file attachments to upload local files, fetch data from public and private APIs and use secrets, and connect to databases. You can learn more about all of these options for bringing data into your notebook in our Introduction to Data notebook and the resources linked there. And don't forget to subscribe to stay tuned for more videos.